right, for today, this warm-up, we accidentally put it a day early, so it is, y'all haven't learned this, but we're going to do it together anyways. The question said, what would the coordinate B prime, what would be the coordinate of B prime if ABC is dilated by the rule xy to 3x, 3y? So, today we're going to focus all on dilations. What does it even mean to dilate? Gets what? Gets smaller or bigger. In this case, what is it going to be doing? What is happening with my rule here? Bigger by how much? By 3. Do you see how it has a 3 in front of both of these? Write this down, please. What this is essentially doing is it's multiplying both the x and your y by 3. So, what coordinate is this question asking about? Which one? What is it asking about? B. It wants to know all about B. Well, where is B on this graph? 1, 1. The B on the graph is at 1, 1. So what am I going to do to figure out B prime? Nope. Times 3. We are multiplying. So how do I multiply 1, 1 by 3? What do I get? 3. 3 is my answer. And that's it. That is all you are doing here. With dilations, everything that you are doing is going to be involved multiplying. You are either going to have to look at the rule or the scale factor to figure out what that is. So that is my B prime. Please write down everything I have written down. Put your warm-up away when you're done, and then get out the notes you picked up and fold them like a book. All right. Please get out these notes for me. A lot of today, most of today, is going to kind of be a review. Do y'all remember before, I know it's been a while, but before Christmas, about a month ago, we learned all about scale factor. Do y'all remember learning about that? And we learned about enlarging and reducing. That's what today is going to focus on. So before we do anything, what does dilations mean? To reduce or enlarge. If everybody can shut their computers and write this down. A figure proportionally. You don't need your computers for right now. To reduce or enlarge a figure proportionally. Dilations are going to produce, if you make something bigger or smaller, is it going to be congruent? No. What's it going to be? What did we learn? Similar. We are producing similar figures. Michael, focus. Does anybody remember what the symbol for similar is? Okay, that's congruent. What was similar? Just the squiggly. I need y'all to write that down. And remember, angles will be the same. Now my rule. Do you see how both of these have an A out front? Your A is your scale factor. So can everybody write A equals right here? And we are always going to be multiplying. We are not going to be adding or subtracting with dilations. We are always going to be multiplying. Does anybody remember how to find the scale factor? We learned this in December. Something over something. Not rise over run. We're going to do something with that. I gave y'all a little something over something to remember. New over old. Or you could put second over first. Or your image over your pre-image. Can you write those down, please? Anybody need a pencil? Y'all have that written down? So let's look at example 1. Example 1 says determine the scale factor from the pre-image to the image. Which one is my old? Which one is my new? The what? The left is old. How do you know? Because it doesn't have any of these primes. So I'm also going to draw an arrow from here to here. Again, your computer should be shut, please. Can y'all shut them? Y'all don't need them right now. And to find the scale factor, I'm going to do new divided by old. What is the length of my new? 5. What is the length of my old? And what is 5 divided by 10? Anybody know? Okay, so be careful. I want y'all to think about this. Real quick. Is this a reduction or an enlargement? Do y'all agree this is a reduction? Does it make sense if you're reducing to multiply something by 2? No. So is my scale factor, is 5 divided by 10 2? No. By the way, if you're not sure, always please divide in Desmos. I don't want a decimal, I want a fraction. So what is my answer? 1/2. Does it make sense for it to reduce by half? Yeah. That is how you are going to do anything that has scale factor. Divide your new over old. Give me the answer. Okay? Number 2 is kind of like the warm-up. Example 2 says, what are the coordinates of E if dilated by the scale factor below? What's my scale factor here? 4. What am I going to do with this 4? Multiply. All you do is multiply. So I'm going to do 4 times 2 negative fifths. What is 4 times 2? 8. What is 4 times negative 5? And that's my answer. Is it really that easy? Yeah. Is that really going to be a test question? Big thing I need you to know is scale factor, you multiply. Do y'all agree everything we just did was review? We did that in December? All right, open up your notes, please. We're halfway done. Yuri, what are the instructions for example 3? By a scale factor of what? 2. If I'm dilating by a scale factor of 2, is that going to reduce it or enlarge it? Enlarge it. It's getting twice as big, it's going to enlarge. Circle that. So what am I going to do to all of these numbers? Double them. Multiply them by 2. What is 1, 2 going to become? 2, 4. What is 1, negative 1 going to become? And negative 2, 2. Please write that down. Jocelyn, you with me? After you write it down, I want you to plot these points. I know this graph is kind of annoying, but plot these points. Did the triangle in fact enlarge? Yeah. By how much? 2. It doubled. What does a rule always start off with? X, Y. And what's gonna, with the arrow, and what's gonna happen here? What did we do to X and Y? So what do I write? 2X, 2Y. And that's your rule. Please write that down. Somebody last period was like, Miss Olivars, what if I put the X first? What if I do X2, Y2? I don't like it, but it wouldn't be the worst thing, but I don't like it. Because I don't want y'all to start thinking you're adding. We're multiplying here. All right, Micah, what does example 4 want me to do? Y'all, this is the exact, well, not the exact same thing, but this is very similar. What's the only difference? If that's your phone, go silence it. It's okay. What's the scale factor of 1/3? Is that going to be a reduction or an enlargement? Reduction. Everybody circle reduction. Now, some of y'all love fractions and can do them in your head. Some of y'all are like, I hate fractions. I don't want to do anything with them. Just use Desmos. I'm going to multiply 1/3 by both of these, 3 and -9. If you don't know how to do that in your head, you can do 1/3 with parentheses. What's 1/3 times 3? What's 1/3 times -9? And do you see how it just gives you the answer right there? So you can do that in Desmos if you don't know how to do that in your head. So my answer is 1, -3. Does anybody know what -6/3 is going to be multiplied by 1/3? No? So let's put it in. -6 and 3. -6 and 3 is going to be what? -2, 1. What about 6, 9? 2, 3. And then please plot these points. Do y'all think it's easier to plot when there are no numbers or when there are numbers? Which one? With numbers? Oh, I think it's easier without. The numbers confuse me. I just like counting. Did this actually reduce? Did it get smaller? Yeah. So what's my rule going to be? How does a rule start off? XY is going to turn to what I do? 1/3 X, comma, 1/3 Y. By the way, for this class, they are always going to be the same. Could they be different? Sure. K-level explores that. We're not going to explore that. We're just going to keep them the same. Any questions so far? Jocelyn, you with me? Yeah, you sure? Okay. Last one on this page, example 5. If I give you point A and the rule, can you figure out the new point A? For the first one, what are we going to do? Multiply by 4. These have a scale factor of 4. So what is 4 times 6 -12? What's 4 times 6? 24. What's 4 times -12? And if you're not sure, what can you do? Plug that in Desmos. So if you weren't sure, you would just do 4 times 6, 4 times negative 12, and you would get your answer. What am I going to do with the next one? What's my scale factor here? 1/6. So I'm going to do 1/6 times 6, negative 12. Does anybody know what 1/6 times 6 is? Yep, she answered the whole thing, but yes, is 1. What's 1/6 times negative 12? Negative 2. So my answer here is 1, negative 2. Again, you are just multiplying in Desmos. I think you have to do them separate, right? I don't think you can do it each. Can you? Oh, I guess you can. Cool. You could do it as one if you wanted. Nice. Any questions on this page? Are we all okay? Did we all write it down? Here, you got it? Okay. I see some people writing, so I'm going to wait a minute. Next slide on over. How do I find scale factor? What did we say to do to find scale factor? Backwards. New over old. Well, first of all, is this a reduction or an enlargement? Do y'all agree the arrow's getting bigger right there? This is my new, this is my, I'm just going to put an O right there because I can't fit old. So this is an enlargement. How do I figure out how much bigger it's getting? Counting what? Count the little blocks. It does not matter what side you count, but you need to do it for both of them. You could do this side, the left side, the right side, the top. It doesn't matter. I'm going to do the top just because it's short, but you could do either one. So how far is this from here to here? My new is 4. How far is the old one? Just a little old one. What is 4 divided by 1? That is my scale factor. New over old. Does it make sense that the answer is 4 if I'm getting bigger? Yeah. So what would be my rule? X, Y goes to what? 4x and 4y. Just multiply. Do I have any questions? Does everybody have a protractor or straight edge at their desk? Does anybody need a protractor or straight edge? You need one? Okay. Anybody else need one? You need one? Okay. You have an extra? Okay. Thank you. Alright, we are just using this. You could also use your badge to have a straight line. But what we are going to be doing is we are going to be using these protractors or rulers to figure out the center of dilation. Can everybody box right here the center of dilation? Normally in here we dilate about the origin, 0, 0. But that is not always the case. If you see the words find the center of dilation, you are going to be using your badge, this protractor, a ruler, and you are going to be connecting corresponding vertices. which basically means connect the corners. And whenever you connect the corners, they should all go through 1 point. So I want you to watch me, then I want you to do it. Can everybody look up at my board? Yodi, look up. Jocelyn, look up. I'm going to connect A with my ruler and just draw a line. Then I'm going to connect B with B and draw a line. I'm going to do C with C, draw a line, and then D with D. When I connected all of them, where do they all meet at? 0, 0. So the center of dilation for this problem right here is 0, 0. I want you to do that now for 7 and 8. You want your line to be long enough. Don't just connect them and stop. You want your line to be long enough so that all 3 lines connect. So look right here. Don't just connect A to A like that. Go all the way through your graph. A to A. B to B. C to C. Did mine cross perfectly at a point? No, it should. Probably this marker is a little thick. If you look, I'm a little off on the A right there. Your question on your test and your questions on your paper, they're going to be multiple choice. So plot the points and see which one is around the closest. I'm going to tell you this one, I believe, should be right around here, which would make this 1, 2, 3, 1, 2, 3, 4. It should be about 3, -5, or -6. Does that make sense? You are connecting the points where they cross is the center of dilation. Again, how do I find the scale factor? New over old. Is this a reduction or an enlargement? Be careful. Look at your primes. Is this a reduction or enlargement? This is a reduction. So what should your scale factor be? Yeah, it should be less than 1. It should be a fraction. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is my old. And what does it turn into? 1, 2, 3, 4. 5 is my new. What is 5 divided by 10? Nope, be careful. 1/2. Because it's a reduction, it's cut in half. Write that down, please. All right, we are going to glue this onto page 39. I see a couple people writing. I'll wait a second. Please glue this onto page 39. You have the rest of the class period, which is over 20 minutes, to do the worksheet I am going to give you. You are going to complete this whole worksheet. Y'all can get up, y'all can move, work with a friend, work by yourself. You're going to do the whole worksheet, turn it in for a grade. And that's all.